So let's take a look at how do we graph sine and cosine function using the unit circle. So we know from the unit circle that cosine function is the x value and sine value is the y coordinate. So we're going to just write to remind ourselves this is the y coordinate. Now, there's a reason that I'm graphing the sine function first versus the cosine function, because it's a little bit easier to look at the values in the unit circle and then graph it right on the axis. Now, I made the scale of the unit circle and the graph the same. So if you take a look, let's look at, I now also put the radian measure for each one for your reference, and you should be very fluent in filling these in too. So this is 4 pi over 4. Now let's take a look at what are the y values in each of these radian measures. So at 0, we know that sine would be 0. So at 0, 0, we're going to put a point right here. Now at pi over 6, which is 30 degrees, we know that the sine value is a half. Now the sine value is the vertical distance, so we went half up. So at pi over 6, which is about 30 degrees, this is 45, so it's probably going to be somewhere over here, so it's about a half. So I'm going to put a point right there. At 45 degrees, which is over here, we know that it's radical 2 over 2. And that's the vertical distance. How far up on the unit circle? So we just go horizontally this way, and it seems to be somewhere over here. I'm going to put a dot there. And at pi over 3, which is 60 degrees, the vertical distance would be radical 3 over 3. Sorry, radical 3 over 2. And we go straight across. Now pi over 3 is 60 degrees, and we know this is 90, so it's probably going to be somewhere over here. So I'm going to put a dot over here. Okay. So next one. At 90 degrees, pi over 2, we know that sine is 1. So at 90 degrees, it's at 1. Now if you take a look, this section over here, which is the first quadrant. So the first quadrant, the sign is positive. So this section, I'm going to just connect the dots. So you're going to just draw a nice curve. It's not a straight line, it's a curve. And this section here, right here, represents the first quadrant. Okay. So you guys can take a minute and try the other 3 quadrants by plotting the y coordinates in each radian measure. So you guys can check your quadrants and your graph and my graph. And if you take a look, in the sine function, the first and the second quadrant are both positive. So notice the curve lies above the x-axis, and you know that the sine value is negative in the third and the fourth quadrant, and it connects with the graph where this sine curve lies below the x-axis. Okay, so this is the model for the sine function. So cosine function. Well, before we go to the cosine function, let's talk about the midline, amplitude, and the frequency. So the midline for this is basically the x-axis. So it's y is equal to 0. Get a pen. The y is equal to 0. Now the amplitude is the distance from the midline to the max, or midline to the midline to the minimum. So if you notice, the amplitude is 1. And the frequency here, or I forgot the period, to add the period here. So period here is 2 pi. And the frequency is how many cycles there are in 2 pi? There's 1. And we're going to talk about other sinusoidal functions that has more frequencies in a period. So cosine. So cosine function is the x coordinate. So the cosine function is the x-coordinate. So you look at the x-coordinates in the unit circle, and we're gonna plot it the same way. So let me just use this color. At 0, we know that cosine is 1. So notice the cosine starts at 0 radian, it's 1 units up. So cosine function starts at 1, sine function starts at 0. At 30 degrees, we know that this is actually the x distance. So we're actually finding the distance. We're actually measuring this distance, the horizontal distance, and then measuring it up here. So the x coordinate on 30 degrees is radical 3 over 2. So about 30 degrees would be over here. So it'll be radical 3 over 2, which is somewhere over here. And at pi over 4, we know that it's the same. That's where the value of sine and cosine is the same. So it's radical 2 over 2, which is probably somewhere over here. And then at 60 degrees, so it was this distance. Now that at 60 degrees, it would be 1/2. So at 60 degrees, which is probably somewhere over here, be 1/2. And then at pi over 2, we know that x coordinate is 0. So it would be looking like this. So if we connect the curve, it will look something like that. So you guys can try the other 3 quadrants. So if you graph the other 3 quadrants, it will look something like this. So notice that the cosine function is positive on the first and the fourth because those are the x coordinates. So notice, look, first quadrant and the fourth quadrant are above the x-axis. And notice the second and the third, which is in yellow and blue, are below the x-axis. So that is the cosine curve from 0 to 2, 5. We just drew one cycle. Now let's see, think about the midline again. Now this is actually the parent function of the cosine function, so the midline is going to be the same. So it's going to be y is equal to 0, but it goes through the x-axis. Amplitude will be the height or the distance from the midline to the max or midline to the minimum. So here it will be 1. And the period here would be 2 pi because it's distance of one cycle. In the parent function, the distance is always, the period is 2 pi, and the frequency is 1 because how many cycles are there in 2 pi? There's only one cycle. Okay, so that's how you graph the sine and the cosine function.